imagery task. So you're sort of engaged, very immersive task, but you don't move your hands. You see these like, everything's around you and it looks like it's your hands, you feel like your hands, you're actually trying to engage. And that we know that fires off brain activity, okay? That one seemed to work. That seemed to increase brain plasticity without even moving your hands. Perfect for stroke. We also tried exercise. So an honours project, a student was riding a bike. We got 30 stroke patients in riding a bike with their legs. And it increased brain plasticity. You can see in the red, the exercise group there. Increased brain plasticity just from riding a bike. Moderate intensity, not hard, 20 minutes. Do that before therapy. Better outcomes when you train with your physio. Thanks very much. Sorry the clicker was causing troubles, but that's it. Thank you. I get to...
It's time for our first door prize, so I'll ask my lovely assistant.
What if it's my mum's? Does that matter?
Well, we'll address that when it comes to it.
What number, Mum? No, I'm just kidding. E31. Oh. E31. Green. Green.
Sorry?
Green E31.
Oh, 31, sorry.
Oh, do you want me to change it? Oh, you got, was that a winner?
Have we got
E Green 31?
Please come forward, sir.
And we're not related either.
Selection of your book.
Is that one?
Okay, great, thank you.
I think you have to point it. Yeah, like I think it's just this.
And here's a, Jonathan, here's a small thank you. You know, he needs your brain power. So now, I'd like to introduce our next tall poppy, Dr. Tatiana Soares da Costa. Now, Tatiana is the 2022 Tall Poppy winner. So there are tall poppies, and then there's the tallest of tall poppies. And she was only just recently announced, so she's all shiny and new and has the new car smell. So let's be very nice to our reigning queen and welcome her. Oh, sorry, before I do that, I should actually introduce you. So the reason that she's one of the tall poppies is, as you'll soon see, she's a very enthusiastic plant biochemist. She's dedicated to ensuring that we can really produce enough nutritious food to address the challenges in the future to feed a growing population. And after her PhD was awarded, she was actually a lecturer at Charles Sturt University to help develop the next generation of scientists. She returned to research in 2015 at the La Trobe University, and then earlier this year she actually returned to the University of Adelaide, where she was awarded the Future Making Fellow, and she is leading a research group focusing on new weed control strategies. Tatiana, welcome.
I have to say, unlike Brenton, my mum is not here because she's actually overseas, but I have my lovely husband in the audience, so I'm really excited about that. I had to embarrass him before I started. He did come to the Tall Poppy Awards session, so it's my second time listening to me, I'm sorry. So hello everybody, my name is Tatiana Soares da Costa and I'm a plant biochemist at the University of Adelaide, fighting the war on weeds. So quick show of hands, how many of you are annoyed by the weeds growing in your backyards? I think every single one of you has put their hand up. Me too. If your backyard is anything like mine, weeds are really setting up home everywhere. They're even growing in the cracks in my driveway. Does it happen to you guys as well? Yes, it's horrible, isn't it? I call it my Thriveway. But this is not only happening in our backyards and driveways, they're happening in farms all around Australia and the world. So weeds have been at war with food crops for many years. They battle for resources like food, water, and sunlight, leading to reduced crop yields and quality. This means less food produced for you and I. But we have allies in this war. They are chemical weed killers called herbicides. So for decades, we have used herbicides to kill those pesky weeds, and they have become an essential tool in agriculture to ensure food supply. Unfortunately, our current herbicides are failing, and that's because those pesky weeds are quite clever, and they have found ways to become resistant to their effects. That sounds like a pretty big problem, doesn't it? Well, it is. So herbicide-resistant weeds have now invaded over 40% of cropping land in Australia. And it's costing Australian farmers over $5 billion every year. To make matters worse, there have been no new herbicides developed over the past 40 years, and our global population is just getting bigger and bigger. We're set to reach 10 billion people by the year 2050. So my question is, how can we keep feeding our growing world population if we're losing the war against these pesky weeds? So I lead a research team at the University of Adelaide dedicated to discovering new and safe herbicides that are less prone to developing resistance. So how do you do that? So we take lessons we have learned from our battles against bacterial superbugs and apply it to herbicide resistance in weeds. From looking at the slide, they don't look very similar, do they? But I have found that they're actually quite similar at the molecular level. So superbugs and weeds can be killed by very similar molecules. So molecules that we use to kill superbugs can be applied onto weeds to kill them. So this could be a game changer in the agricultural industry, as it could help us develop herbicides much more quickly and cheaply by leveraging research that's been done against superbugs and applying them to herbicides. So using this approach, we have discovered molecules that can attack weeds in multiple ways simultaneously. It's like killing two birds with one stone, but in this case, killing two weeds with one herbicide, making it much harder for weeds to develop resistance to these molecules. So by combining exciting science, innovative approaches, and environmental awareness, we are hoping to find a safe solution to our pesky weed problem. So my research is trying to help farmers by giving them the tools they need to overcome weeds. That way, they can keep producing enough nutritious food to keep feeding our growing world population. It's also going to give us the tools we need to fight those pesky weeds in our backyards and driveways, so they're no longer thriveways. Thank you.
Thank you so much for that explanation, Tatiana. Right now, my garden is being overrun with weeds, and at some point, I've got to get out there and deal with it. So, thank you. I would now like to introduce Associate Professor Yuval Yarom. Dr. Yuval Yarom is the 2020 Tall Poppy. His research explores the security of the interface between computer software and hardware. He completed a bachelor and master's in maths and computer software in Hebrew University and spent many years working in the IT industry, working in Memco Software and co-founder and chief technical officer of Giraffe.com. He completed his PhD at the University of Adelaide and is now working as associate professor at the School of Computer Science. Welcome.
Thank you very much for the introduction. It's a pleasure to be here. I'm sorry I didn't bring family members with me. I was introduced as a young tall poppy, and as you can see, I'm not that young and I'm not that tall. I guess that basically I'm aging fat geek. Okay, now I need. Yes, it works. So, I haven't always been like that. As you can see, I have been young and I've been slim, but I've always been a geek. And as a geek, I had a dream. I wanted to be a scientist. And not just any scientist, I wanted to be like Luigi Galvani. And Luigi Galvani is the dream of every young geek, because nothing is better than channeling to 20,000 volts through something that was live, particularly when you're being bullied. This really gives you some escape. Anyway, long story short, I grew up, I became a scientist, and my work is actually not that different than what Luigi Galvani did. So if we look, Luigi Galvani was experimenting with frogs and basically sending signal to the frog and making them twitch. And in my work, I experiment with computers, and I send signals to make them twitch. And now, why is that important? So if we look at computers, computers are the modern age biblical equivalent of the biblical plague of frogs. They are everywhere. They do everything. We use them for banking. We use them to access our health services. Let me ask a question. Who brought with them a computer here? Yes, everyone. Who brought more than 10 computers? Everyone. This thing has 15 computers at least. Okay, so everyone has computers. They're ubiquitous. They are everywhere. We have them. We don't even know that they're there. Washing machines have them. Cars have tons of them. Everything has computers. And that means that these computers process all our secrets. Everything that we do, everything that we don't want to tell anyone is there. And we just don't want this to go out, to be revealed. And we want to make sure that they really do what they want. Now, what I do in my work is basically investigate how these computers deliver the security. Bottom line, they don't. Now, we'll try to look at that and see some of the reasons. And here is my programming lessons for today. Will not be more complex than that. How do we protect data in computer? Computers are very simple. They follow instructions. We tell them what to do, they do. They are stupid. They don't think about that. They just do exactly what we say. And in this case, we have some data in the computer, and we want to reveal the data to show it to the user, or to anyone who works with the computer. And we tell the computer, check whether this data is secret. And if it is not secret, reveal it. And that's the way that we do protection. That's how we protect secrets in computers. So we take some time to check, and then we take some time to reveal data. And now, what we have discovered, or it's something that people most of knew, but we didn't know the implications, is that computers, like people, they develop habits. We develop habits to be more efficient. We develop muscle memory to do things without thinking about them. And computers do the same thing. And in the case of security like that, what they try to do is, it may take some time to check whether data is secret, so they start revealing the data while they are also testing whether it is secret or not. And this is good if the data is not secret. But if the data is secret, then that's not good. Fortunately, the designers are not stupid, obviously. They designed the computer to roll back everything that was done that it was not supposed to do, and then continue as if nothing happened. What we found is that, yes, they roll back almost everything, and we developed techniques to reveal the information that was not supposed to, and that creates a problem. How big the problem was, and when we found this, when we disclosed it to Intel, Google, AMD, all of those, visiting a website was enough for the website to take everything that was running on the computer. That means access credentials to banking, everything that your browser was watching, everything in the computer eventually. So we told that to all those companies. Actually, Google were part of the discovery. We worked with them to create initial fixes. Since then, most of the work is we're discovering more habits that computers have, and are working on fixing those before bad people do that. And in summary, we rely on computers. They do follow habits, and we can use them against them. Thank you very much.
So, it's time for another door prize. And again, I'll ask this lovely young assistant, pick out a ticket.
Yeah, unbiased, yes. we have green E004.
Green E004. This is science, so we need empirical evidence.
Proof is required.
Pardon?
Proof is required.
What would you like to come to the front anyway? You'll need to. Also, let's hold off the applause. As I said, let's make sure the data is correct. The data is correct. Thank you. So I'll now ask the three speakers to come up and join us on the stage. So Tatiana and Brenton, please join us. And in the meantime, as they're coming up, something occurred to me. I was so busy making sure that everything was running correctly, I completely forgot to introduce myself. So I actually was invited to be the MC. I'm not some random person who wandered up. My name is Dr. Pallavi Dasri. I'm one of the conveners for Science in the Pub Adelaide, and I do a lot of this science communication. In my past, I was a breast cancer researcher. Now I work in the Office of the Chief Scientist. So thank you all for bearing with this strange person who was just coming over and telling people what to do. We are now going to be in the Q&A part of the evening with these three speakers. So I hope all the questions that was arising in your mind as they were talking, you've got them there. We'll be passing over to you. Remember, children, if you ask a question, you're guaranteed a prize. And adults, if you ask a very good question, something that entertains Catherine, you might get a prize as well. So who's first? Hands up. Yes, sir. Oh, hang on one moment. There's a mic coming towards you.
I have lots of questions. Well, two basically.
We'll just put one to start off with.
Okay. This is dedicated to my brother who died of glioblastoma. In your strokes, is it a nerve growth factor system going on? Could you stimulate extra nerve growth factor with the training and improve the outcome of the stroke recovery?
Yep. So when we're talking about stroke recovery, that's different to stroke survival, first of all. So stroke survival is all about restoring blood flow to the brain, which they're getting better at, is the short answer. I'm not a neurologist, but they've basically extended the window with which they can give you a drug to help blood flow restore to your brain. And there's a really good protocol in place. So if you have a stroke right now, I can tell you which hospital you go to, and within the hours you'd be getting the appropriate drug and probably walking out of hospital tomorrow. With recovery, it is all to do with what we call neuroplasticity, and there's lots of different mechanisms of neuroplasticity, and you mentioned stuff about nerve growth, and there's things like synaptogenesis and synaptic plasticity, and I can name quite a few. What we can measure is something called synaptic plasticity. So you've got all these neurons in the brain, and there's little tentacles that connect up to different regions. So the quickest form of plasticity is when you change the efficiency of those connections. But there are other forms of neuroplasticity which are very slow and they take a long time. So neurogenesis, so growing new neurons. So what we probably are, it doesn't actually matter to me as a physio what mechanism of neuroplasticity it is. Does the person get better? How can we help them get better? What we're probably actually working at is the more quicker forms of neuroplasticity, which is synaptic plasticity, which is what we measure in our humans that we tested.
Thank you.
Hi, I'm asking on behalf of my daughter. So she has. Pardon?
Is that for a prize? Or?
No,
okay.
she's not here. How does like the research you've been doing have implications in like genetic and birth defects? So my daughter has cerebral palsy from birth, and so there's brain damage.
Yeah.
Does it
So
have the same?
So I don't work in cerebral palsy, but believe it or not, my wife is a physio who works in cerebral palsy. She's not here tonight. She's looking after the kids. Very similar to stroke. What I do know is pediatric stroke, which again is very similar to cerebral palsy. The recovery can be quite good, and in fact, kids so neuroplasticity changes over the whole lifespan. And the best example I've got from my experience, I bought a skateboard. I tried to learn to skate, I couldn't do it. my kids who are between, I'm looking at my mum to help me, 3 and 8-ish. Yep, I've got a thumbs up. They picked up skateboarding straight away because the kids have much better neuroplasticity. You just imagine if you try and learn a language now, but a child learns it, they would learn it much more efficiently. So there's lots of factors that come into play. Can we assume that neuroplasticity is greater in people that have cerebral palsy? I'd say yes, because they're younger. Cerebral palsy is something that they think happens at birth, I believe. So obviously, if there's a window where the brain's most plastic, it's going to be very, very young. But at the end of the day, what you're trying to do, I would think, for any type of rehabilitation is provide them opportunities for training so they can get better at movement. So like anything, just practice makes perfect. Yeah, happy to talk about it a bit more afterwards if you want.
And we have a question here.
Hello, this is for Yuval. Just in regards to where the data is being made secret or made, not secret, is that at the process level, operating system level, or at the actual application level?
Okay, actually in almost every level of the processor it can happen. It can be in the program when you actually have explicit tests, or it can be in the processor itself when a program tries to access memory that it is not supposed to be able to access, and we can read it, or could. Can't happen more these days.
And there's a question here.
Tatina, you said bugs and weeds are the same at molecular levels, so you can target both. What kind of bugs can you target?
So my background is actually in antibiotic resistance, and so I was looking at bacterial superbugs, the ones that cause a lot of diseases like meningitis, pneumonia, tuberculosis. And when I was looking at the structures at the molecular level, I found they were very similar to what we're finding in plants. And there's been a lot of work done on superbugs over the years, obviously, because superbugs are everywhere and they're claiming many lives every year. But we don't know a lot about weeds. Weeds have been one of those things that we get annoyed by, but there's not a lot of research done on understanding, how they become resistant and all that. So I thought, can we apply some of the knowledge we've got, that we've been learning over the past 20, 30, 40 years, and apply them to this field so we can speed up the discovery of herbicides? And that's what we've been doing. So we've been learning about what's happening, those nasty bugs like golden staph and these bacteria, and seeing whether we can apply the same principles to those pesky weeds in our backyard. So yeah, great question.
Thank you. And Catherine, my earlier point about if children, if they ask a question, automatically get a prize, I think this audience member deserves one.
Yes.
Would you just like to put your hand up so Catherine can give you?
Is it?
Oh, and there's one here.
I have two. So, Brenton or Tatiana, who wants a question? Tatiana?
Fight for it, yeah.
Obviously, antibiotic-resistant superbugs are a big problem. What are we learning that's going to stop this from happening again, but this time from a botanical point of view?
So I'm assuming that's for me. Do you want to take that, Brendan? So we have learnt a lot about the mechanisms of resistance. So how are these superbugs becoming resistant to therapies? And we actually found that some of the mechanisms are actually quite similar between superbugs and weeds. So we're trying to be cleverer than the weeds are, and in being one step ahead of them and thinking, well, if they're going to develop resistance to this, can we make a molecule so that can't happen? So we're trying to stay always one step ahead and try, but that's always harder because they're cleverer than what you think. So they're always changing their makeup to make them resistant to our current herbicides. But so that's one of the lessons we're learning. We're also trying to learn what types of molecules work, against certain targets. So that's giving us clues. But the thing is, we can't just give a medicine to weeds, right? Because they could actually kill important bugs or bacteria that grow in the soil that are quite important for crop health. So we can't do that. So we have to change their structures a little bit so they're more plant specific. So that's what we're trying to do. We're trying to get some ideas from superbugs, but also we need to make sure they're weed specific. So they're not affecting our animals, our soil microbe, humans, for example. So they're only killing those pesky weeds and nothing else. So that's what we're trying to do.
Thank you very much. Now we have a question here.
I heard of something that can be used against superbugs called CRISPR-Cas9. You said that superbugs and weeds are similar. Could we potentially use it against weeds?
Yeah, so that's a great question. Have you learned that at school?
No, I learned on YouTube.
That's amazing. YouTube is a great source of information. So CRISPR is a way of us, changing the genetic makeup of organisms like superbugs or weeds, for example. We're actually using CRISPR in our lab. So do you want to come and work in our lab when you're a bit older? We'd love to have you. So what we're trying to do with CRISPR, actually, we're trying to knock out some genes. So take out some genes in weeds and see what the phenotype is. So if you take out gene X, what happens to the weed? Do they die? If they die, well, that must be a good herbicide target. So that means we're going to develop molecules against that target. If they're living and thriving, we're not interested in that target because it doesn't matter if we make molecules against it. The weeds are still going to live happily ever after. So that's how we're using CRISPR to understand what parts of the plants are really important so we can target them. And if we can take out that gene and the plant dies, voila, we've got a great target. So how old are you now and what year are you? You're 10, so maybe, where's your mum? When can you come? Oh, Dad? Yeah. When can you come and work in the lab? Maybe in 4 or 5 years? Are you keen? Yeah, of course. He knows about CRISPR already. That's amazing.
So, Catherine, I think not just the regular prize for him, but the fact he asked about CRISPR-Cas9, I think it's also a bit of merchandise or something. I'll leave it to your choice. Best question as well so far. So, Finley, if you just want to go and see Catherine, please. Any other questions? We do have a couple of minutes left.
Thank you. This question's for Brenton. Just in regards to the practical applications of your research, it's clearly evident that exercise and early stimulation is key to having that increased robust recovery at the beginning for a sustained recovery.
Yeah.
Would you consider one of your applications in the clinical field to encourage multiple disciplines then be engaged in the exercise? So nurses, OTs, physios, not just physios who are there for a very brief window?
Yeah, so a couple of things. So I guess, so what we don't know, so what we've tested on is chronic stroke. So what we don't know, if you have a spontaneous increase from the damage to the brain after a stroke and it increases neuroplasticity, if you then try and increase it more with exercise or brain stimulation, what does that do? And the short answer is it's probably actually detrimental. So what I would say, first of all, as an inpatient, so early after stroke doing rehab, so I used to work at the REPAP, we would, one of the challenges is actually giving a good amount of, do you work at the REPAP? Is that what that look was? Yeah? Okay, yeah. So one of the challenges is, as you probably know, everyone's busy and it's just hard to get like hours of therapy into a patient. I work now at the UniSA Health and Medical Clinic, seeing patients but research as well, and that's in chronic stroke. And that's where we're trying these things. Can we reopen that window that we get early? And it seems like we can. So what we do, what our thing about our clinic is that we, test and evaluate new ideas, and then we rapidly offer them to the clinic, to the community. So if you come to our clinic, you can get brain stimulation as a therapy, if you've had a stroke, not just for fun. And we would pair that with physiotherapy as well. So the idea, so we're working at that stage, we're outside that spontaneous period of increased neuroplasticity. We're trying to reopen it later on.
Actually, to Yuval, your work around computer science, I wanted to ask a very technical question, if you could answer it in under a minute. Quantum science. What is quantum? I've heard that it's really going to knock out our systems and that the defense sector is really interested in it. What is quantum? Is it the next phase?
So it is a very interesting question because first, quantum it exploits the effect of quantum. I'm not physicist, so I'm sorry. It enables storing much more information and computing it in a different way that renders all current cryptography, or most current cryptography, useless. So it can break current cryptography. Now, we don't know whether we will be able to ever build quantum computers. For the past 50 years, we have always been 20 years from a quantum computer. We are moving forward. They are improving. So it's not that it is really 20 years, but we see advances in the area. So there is a risk. The problem with cryptography is that if we want to protect the data that we have now, 10 years from now, then we need to already have cryptography that is resistant to quantum computers, because when they come, they will be able to break everything that we communicated today. And getting new cryptography into the market takes at least 10 years. So we are currently already behind.
There we go. So I don't know about you, but certainly my stomach is grumbling, and I'm sure some of you would like to just grab a snack to eat. So we're now in the intermission, and we've got about 15 minutes or so. If you'd like to head over there to pick up your dinner, and then you can just go and sit in the library and just enjoy being in the books. We will come back at 7:10. So I've given you a couple of extra minutes, 17, 18 minutes. Thank you so much. rested, well fed and refreshed. And although Dr. Dominic McAfee would have loved to be here, unfortunately he's had to zoom in. So he'll be the first speaker for the second panel. And he's the 2021 Tall Poppy, and he's actually a marine ecologist with the University of Adelaide. So he deals with the sticky stuff, raising public awareness. Extinct reef.
In lockdown up in Queensland, and it seems everyone has come home with COVID. So that's what we get, mingling with lots of people. But anyway, with a particular passion for shellfish reefs. Oyster reef in Australia. It's in Tasmania. We don't have any in mainland Australia, but we have just this one reef, which we can look at in Tasmania as a bit of a blueprint for what these oyster reefs used to look like. But today it's primarily bare sand. We dredged every single oyster, living or dead. We ate them, and if they were dead, or even if they weren't, we burnt them. And with the burnt shells, we could actually make cement. So it was a really useful product that we used a lot over the last, over the first sort of century of European occupation in Australia. But we're doing something about that now, finally. After 200 miserable years for oysters, we're bringing them back. And we're doing that by building these underwater reefs using limestone boulders, where we build these reefs a few metres off the sea floor. They can be pretty extensive. And from hi Zach, that's a student, from 2015, when we built our first reef, we're already up to about 50. We're restoring thousands of hectares of oyster reefs in every coastal state of Australia. So it's a very exciting time for oyster reef restoration. We're bringing them back quite quickly. In South Australia, we've already constructed 3 reefs in Gulf St Vincent, covering about 30 hectares. And this year alone, we're scheduled to construct potentially another 3 on the Kangaroo Island coastline. So these reefs consist of thousands and thousands of tons of limestone boulders. That provides hard substrate for little tiny baby oysters. Before the familiar cells that don't move anywhere, they are tiny larvae looking for a place to live. And so we build this rocky substrate, and that provides a place for them to settle on. In the past, they would have settled on other oysters, but all the oysters are gone. So we can build these reefs and provide a home for them to settle on, but how are they going to find them? How will these little tiny little larvae floating around in the water find a place to live? For a long time we thought that larvae would just move passively with the currents, but we now know that that's not quite true. They use a bunch of different environmental information to find a place to live. And something that they use, and that we use to improve our restoration outcomes, is marine sound. So sound works much like the way we use sight on land. And that little picture in the top, I don't know if you can hear that. I'm playing a sound file at the moment, which basically sounds like the crackling of frying bacon. So it's this intense crackle sound, lots of pops, and that's created by millions upon millions of tiny animals called snapping shrimp. They have this modified claw. When they do a quick snap, they create an air bubble. As that air bubble collapses, it creates the snap, and that sound draws all sorts of animals in, fish and abundance of different types of larvae, including oysters. That picture there is actually the picture of we call that a spectrogram, and that shows a really intense sound of what a healthy reef sounds like. But because we've removed all the oysters, there's no sound left, because the snapping shrimp live in amongst the oysters. So now we have lost reefs, and they don't make any sound, which means that marine larvae are lost at sea. They don't know where to go. Reefs that have been restored over a couple of years, they start to get some of that sound back. What we can do is actually use speakers to reproduce those sounds, so oysters and other marine animals will know how to find our reefs. So we put speakers. Marine speakers can be quite expensive, and so we make our own speakers using all off-the-shelf parts from Bunnings and Repco and other places like that, where we use PVC piping and car batteries and very, 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 very cheap speakers. They cost about $20 off eBay. And we encase that in the PVC piping, we put them down in our reefs, we play the sound, and that drags oysters in, which can actually listen to those gradients in sound and follow them towards the reef. We've done that in partnership with a group called Ocean, which are a South Australian environmental conservation group, which developed this technology. And in playing sounds, we've shown that oysters will actually swim towards those. Yeah?
You're running a little bit over time. How are you doing?
I'm on my last slide, I think. Oysters will swim towards these reefs, and I don't know if you can hear that, you're not supposed to, but what we find now is that even after just a matter of months, this particular reef is about 12 months old, and you can see incredible amounts of oyster recruitment already on these reef boulders. And that's a reef that's been accelerated using reef sound. We've also got transplanted kelp there. I obviously don't have time to go into that. But it looks like we can restore these reefs within a matter of years. So thank you very much for listening.
What I'll ask you to do is to stay online, but we are going to have our other speakers, and then there'll be a panel session, which we can have both virtual and in real life. So you'll see our faces again very soon.
Sure thing. Thank you. I'll stop sharing.
The joy of COVID times and doing things through online and in real life format. So now I'd like to introduce our next speaker, Dr. Julianne Popple. Dr. Julianne is the organiser of the Australian... Have we started at the beginning? Okay. So Julianne is the convener of the Australian Institute for Policy and Science, and she's a science communicator who loves bugs, such to the point she did a PhD in it. She grew up in subtropical Brisbane, chasing anything that moves, so she's really into nature, and she's promoting excellence in science. And she's got such an interest in science, not just in her area, but also in the Australian Space Discovery Centre. She's now proud to call Adelaide her home, as well as the home of Australian Space Agency. And just to give a quick shout out, it is actually quite wonderful how the Australian Space Agency, which is the national body for the federal government for space, much like NASA, is actually housed in Adelaide, along with the Cooperative Research Centre for Smart Satellites, along with many, many smaller organisations and businesses that work in space. We actually are one of the space centres of Australia. But I'd like to introduce Dr. Julianne to talk about her favourite topic.
Okay, thank you so much, Pallavi. So I, like some of the other speakers, have brought some family along tonight. My husband, don't know if he's heard me talk before. We had a conversation about it, and either I was really boring or he's never heard me. Hopefully it's the latter. And my little daughter Ella there, who's 5, so she's come to hear me tonight. She's very excited to hear Mummy speak. Thank you. So, one of my awesome day jobs is I get to work at the Australian Space Discovery Centre. Now, if you haven't been, it's on Lot 14 on North Terrace, where the old Ra Hospital site was. and it's free to go. So I do encourage you to go and check it out at your earliest convenience. So, space. As Palaver mentioned, I love bugs and I love space, my two favourite topics. So we're going to play a little bit of a game tonight, and I like to call it, Is It Space? Now the premise is very simple. I'm going to show you a picture, and I want you to respond to me if you think it's space or not space. Very simple. If I show a picture and you think it's space or space related, I want you to yell out, space, right? And we'll test it in a minute. And then if you think it's not space, you just say, not space, okay? Let's test with the very first, very easy slide. Yes, thank you, Ella. Yes, definitely space. We have an astronaut in space, floating above the Earth. Slightly terrifying because they're testing a backpack and they're not tethered. I mean, a jetpack and they're not tethered, but happily the astronaut was safely recovered. So a classic image of space and what we tend to associate with space. But actually space influences our day-to-day lives in many, many ways. What about this one? Ah, you say that. But this is where I combine both of my loves, space and bugs. This is space. The very, very first living thing sent into space, strapped to a rocket, was a fruit fly. And it's not to get rid of them. Not that fruit fly. That's the Queensland fruit fly. This is the classic fruit fly, Drosophila melanogaster. It's a great species. It's used in many scientific studies in the lab. One, because they reproduce really, really quickly. And two, because even though they look really different, they're actually genetically really similar to humans. So we can study the effects on radiation in space, for example. And in fact, in 2006, they sent, I think, 15 flies up on a rocket. After several days orbiting around Earth, they came back down, there were 3,000, which just gives you an idea on how fast these guys breed. And they're going to set up a special research station on the ISS, the International Space Station, just looking at fruit flies and how space can affect immunity, immune systems, because space affects us in lots of different ways, but immune systems is one of the ways that space can affect us. So, yes. Next one. You're a little bit more hesitant. Come on, take a gamble. What is it? Oh, we're divided here. Not space. This is a courtroom in Texas. It's about as far from space as you can get, although everywhere on Earth technically is 100 kilometres from space. I digress. But space lawyer is a job. If my satellite crashes into your satellite, who are you going to call? Space lawyer, exactly. And it's, more seriously, it's to deal with more ethical issues like who can mine the moon, who owns things in space. We have treaties to say that no one owns things in space. But as we go further into space exploration, we're going to need to sort out these things, and we're going to need ethicists and lawyers working in the space industry to help us navigate these tricky issues. Space. Yes. And what we see here in this particular image is bushfires along the eastern coast of Australia. And, you don't see much through the smoke and haze, but with satellite imagery and satellite technology, infrared imagery, we can cut through the smoke haze and see where the bushfire fronts are, and then inform crews on the ground as to where they need to go in order to better tackle bushfires, which is another example of how space technology is really, really useful, not just on your smartphones for navigating from A to B. Not space. Yes, correct. Excellent. You guys are doing great at this. So, definitely not space. Graffiti artist doing, brightening up the city streetscapes, really cool. But, once again, images like this are made by artists, conceptual artists who are there to inspire us about Australia's role in space and the future for the Australian space industry. For example, in this image, I see a lot of different jobs involved. We've got engineers, astronauts, scientists, people on the ground, ground control, someone's got to do that. We can't all be Major Tom. And I see a lot of rovers in there, and Australia is going to be involved in the Moon to Mars mission. We are going to be sending a rover to the moon. So even though this is a concept, a dream of the future, very soon science fiction will become science reality, which is really, really exciting. And who knows, particularly some of the younger people in the audience, although it's never too late for a career change, you might find yourself looking for a space career. You might be the next engineer or programmer who programs a robot, or any one of these jobs. You could be an intelligent game designer for any of those interested in video games, arranging simulations for astronauts to learn how to navigate the space environment. And as you'll slowly see, you might have noticed, the eagle-eyed viewers in the audience, we're forming a rocket. Yes, because we love rockets in space. But that's just a sample of some of the careers in the space industry. And over the next year, up until 2030, we expect there to be 20,000 jobs in the space sector. And a lot of those are happening right here in Adelaide, which is the heart of the Australian space industry, which, I don't know about you, I find that pretty exciting. Thanks so much. E064. E064. Does anyone? Oh, please come forward, sir. Let's check your ticket. Thank you so much.
So after that really engaging speech about space, which I didn't realise there were all those professions, I'd like to now introduce our next tall poppy, Dr. Sarah Cohen-Woods. She was the 2019 Tall Poppy, and she's someone who's really curious about neuroscience and psychology and how that all ties in together. She trained extensively across the UK and Australia, building her knowledge and experience in genetics and developmental psychology, before then moving to Adelaide to then drive her research into behavioural genetics and environmental mechanisms. So Sarah, please come and join us.
Hello, I feel a bit short. Oh well, that's okay. There you go. But I'm not going to sing. So I'm going to talk to you about when psychology meets biology, because I'm a bit of a weird mongrel in what I do. I originally trained in psychology and then decided it'd be a great idea to do a master's and PhD in molecular biology with zero training. That's fun. So what I'm going to talk to you today... Oh, my slide's not working. We're just going to roll with it. I'm going to talk to you today about what it is that makes you, you. And a big part of that is about our bodies, our genetics, our environment, and our experience. You know that you get some of your genes from your father, half of your genes approximately from your mother, and that contributes to you, but also your parents are the ones raising you. I'm going to take you on a whistle-stop tour of my lab, and all of my formatting has gone wrong, but I'm going to roll with that too. A whistle-stop tour on my lab and life's journey, and what we're covering on the molecular side of our research. Now, at the beginning of your life, you inherit these genes from your mother and your father. I've got a question for you guys. How many people here have been touched by mental health? Not personally, like also with other people. I know otherwise that's a very confronting question. Apologies. Stress. How many people have experienced serious, significant stress? These are all really central tenets of the research that I do. So you know you inherit genes from your mother, you inherit genes from your father. But what does that actually mean for what happens to you in your life and your behavior and your mental health outcomes? Well, it might surprise you to know that almost all behavior has a genetic basis. Now, I get some nods and then I get some looks of horror about that. But there's a lot of evidence for that. I can tell you another time how we figured that out. Now, in our lab, a lot of the work we do is looking at molecular genetics. We've identified multiple genes that increase the risk for particular disorders altogether. And what we've recently found, for example, is that genetics that increases the risk of anorexia nervosa, that's a really debilitating clinical condition, eating disorder. It also actually increases the risk in the general population. So a room like this for just disordered eating, well, not normal disordered eating, but the normal continuum of eating patterns. So why is this important? Because if we find ways to identify people early who may require intervention, we may be able to help people sooner. And we know early intervention is key in these conditions. So does that mean, if I tell you that everything has a genetic basis, do you now feel, oh my God, it's inevitable. I have no control over my life. Does anybody, not necessarily that extreme, but does anybody feel a little bit like, hold up, now it's inevitable? No, I've got nothing to convince you of. One person, thank you, I'm running with you. Excellent. Well, the good news is it's not necessarily inevitable because we're not just made of our genes, but our environment is a really central part of our lives as well, which we also have with our families and outside. And the other bit of my research is looking at understanding how it is that the environment may influence our genetics to develop particular conditions, right? Now, I don't know if any of you have heard about epigenetics. So epigenetics is probably the thing that monopolizes a lot of our research. And the way I like to explain epigenetics, because people have a relatively good grasp of genetics, is that there's a piece of music there, right? Those musical notes, that's your DNA code. That's written down. That's what it is. It's for the period of time that it is. But you see those annotations, those scribbles on top? That influences how that music is expressed, and that's your epigenetics. So epigenetics influences your gene expression, musical expression, without changing that DNA code. So we're looking at how epigenetics may influence your DNA code to alter the outcomes down the track. Some of the work that we've done, for example, we've found that socioeconomic status, which some of you may be familiar with, may not be familiar with, we've found that a low socioeconomic status, so people who are struggling more financially with familial support and that sort of thing, that there are epigenetic changes on their genome in stress-related genes and genes important in molecular aging and biological aging. What's more is that we've found that those same genes may explain some of the relationship we know exists with these adverse conditions with mental health outcomes, specifically depressive symptoms. This is unpublished, guys, don't tell anyone. But it's all very interesting. But the big point of this is that it's not just your genetics. Without a stressful environment, it might be that your genetics doesn't actually precipitate in an eating disorder or a depression episode or otherwise, okay? Now, on our life journey, my life journey's disappeared because who needs formatting? It was also orange, and now we're blue. But that's okay. It's okay. On our life journey, we're coming back to the baby now. I wonder who I'm going to surprise with this. Did you know that your life exposures can influence your children? Did you know your life exposures can or are correlated with outcomes of your children to do with life exposures before you conceived them? So there is a lot of evidence of preconception stress being associated with poor outcomes in the children. So this is stress before you've made the baby, and the children have worse physical and mental health outcomes. So initially, when I heard that, I was a bit like, meh, whatever, because, you know, parents raise the children, maybe they've had trauma, they raise them differently. But no, it's been to the level of when babies are born earlier, and they're born with lower birth weights. So it's very clear that there's something perhaps more or less psychological, if you like, going on. And I hate to say that because everything psychological is biological, if you're me. But anyway, so that brings us to our latest piece of research, which has got to do with, if this works, looking at, so while this is an emerging part of research, oh, there we go, they've come. A bit slow to the party, we won't talk about that. So the latest bit of research that we're doing is trying to understand if that intergenerational inheritance of stress is passed by us, by germline through the sperm, if it's possible to pass it to the next generation. This is all very new. I can't tell you any answers yet because we are still doing the research. We got the data this week and my clicker is still not working. Oh! So what I want to quickly wrap up with is we've shown you about DNA, explained to you how DNA can contribute to your behavior, but hopefully I've explained how the environment can also modify that risk. And in turn, we're now exploring this idea of intergenerational epigenetic inheritance and if it's really actually a thing. I'll hopefully be able to tell you next time about it. And I'm trying again. What am I pointing it at? Well, there you go, scientist. So my question to you about life's journey is if knowing this information, if this might change anything about what you do and what you engage in. If you know that you've got a genetic risk for something, say cardiovascular disease, to make it very simple with a very clear intervention, are you now more likely to go for a run knowing that can affect that genetic risk? And the reason I ask you that is because whirlwind tour number 2 might be psychoeducation, something else that we're working on. Thank you.
Thank you very much for that, Sarah. It is actually really fascinating how what your grandmother did could actually affect you well before you were, before your mother was even conceived. Now, I've just actually got an announcement. Is there on Twitter a @mashedpotato88? Is there an @mashedpotato88? Well, as I said, there was going to be prizes for people who tweet about the evening. And so, Catherine, if you'd like to give something to @mashedpotato88, because she's talking about what a lovely time she's having at Science in the South, Science in the South on Twitter and broadcasting it. So thank you very much, @mashedpotato88. And remember, it doesn't just go to mashed potato, it goes to all other food groups that decide to tweet as well. So now I'd like to introduce our last, most definitely not least speaker. Associate Professor Ian Moffat is the 2020 Tall Poppy. He's an Associate Professor in Archaeological Science with Flinders University, where he undertakes research and teaches using earth science techniques in archaeology. He's held research positions at the University of Cambridge in Mediterranean Studies, and he did his PhD at ANU. In addition to his academic career, he has worked at Ecophyte Technologies, Precipice Training, and Archaeometry Proprietary Limited. Ian, please.
So, thank you so much for having me tonight. I'm going to start out by breaking some hearts. I'm going to let you in on a secret that Indiana Jones is dead. Now, I know you see me standing here. I'm ruggedly handsome. I look like I could fight Nazis with a whip. But archaeology has changed and is changing all the time. And the research that I'm doing and that my research group are doing are taking advantage of this change to ask fundamentally new questions of the archaeological record. So who here has actually worked on or been at an archaeological excavation? Hands up. Good, you all have to come along and see how it works. But the thing you would find, the thing you probably found, is that when you're in that excavation, you're digging incredibly slowly, you're getting lots of information about one particular place, but it's really hard to get outside of that tiny area and understand the archaeology more broadly. So this was one of my students in an excavation in northwest Queensland, and it took us about 3 months to get down to this point. So it's a lot of time to find out just about that one spot. But if we use new scientific techniques, we can look much more broadly across the landscape. So we can all of a sudden see where the archaeology is spread on a much bigger area. And we do this using techniques from the earth sciences, so geophysics, geochemistry, sedimentology, 3D modelling, new innovative ways to understand archaeological science. So let's start with a little thought experiment. If you were tasked with putting one 1 by 1 metre excavation anywhere in Adelaide to understand everything about the city, where would you put it? Does anyone want to jump in? Yeah. Rubbish dump? Rubbish dump's a great answer. But people often say rubbish dump, they want to do it on North Terrace, they put it somewhere out in the suburbs, and each of those places without context will give us a completely different idea. of what's happening in Adelaide. I mean, if you went through my rubbish, you'd see I'm a person of very refined taste, eats very well, but you could go next door and get a completely different idea. So the only way to look at the archaeological record in a more holistic way is to find a way to image underground. And so I use geophysical techniques, satellite techniques, aerial techniques that can see down into the subsurface and give us information about how the archaeological record is spread over a much broader area. And if we do this, we still probably need to dig, but we can dig at the places where we know there's a specific question to be answered rather than just digging blindly. On the right of the slide here, you can see a classical Greek city in the Peloponnese, and the straight lines that you can see in that data are the ancient streetscape of that city. So it's buried beneath an agricultural field. We have no idea what was there, and by using these geophysical techniques, which maybe take a day or two in the field, we can suddenly unwrap all of that wonderful archaeological potential. And then if we do find those sites, we need to look at the archaeological material in different ways. So this is what a Neanderthal looks like, both on the stage and on the slide. And if you think about the type of material that comes out of archaeological excavations, things like stone artifacts, other material culture items, bones, those things are great at giving us information about specific parts of how people and our ancestors behaved. But what they don't do is tell us about a whole bunch of other stuff that just doesn't show up in archaeological science. And so what I and my students have been doing is analysing the chemistry of teeth and bone from archaeological sites. You can see on the image on the bottom left a slice through a Neanderthal tooth, and we're mapping the chemistry of that tooth in really high resolution. And this can give us information about how diets are changing, about how these ancestors are moving around the landscape. And in this case, and hence the baby Neanderthal, the maternal behaviour of our ancestors. So how long they were breastfeeding their children for, and whether they breastfed in one continuous block or they returned to breastfeeding over time in response perhaps to climate stress. And finally, if we can understand the archaeological record in this new way, we need to find new ways of sharing it. So I've worked a lot in Arnhem Land on this absolutely stunning rock art record up there. And one of the issues that we face in this area is that our traditional owner partners have many elders who aren't able to experience the rock art sites for themselves. Perhaps they're quite a stiff climb up the hill in some instances. And so we're developing new techniques to create immersive virtual environments so people can experience these remotely. But also, these immersive virtual environments can be a new tool for understanding the archaeology. So one of my brilliant PhD students has reconstructed the entire landscape of the valley that we're working using drone data, and he's created essentially a video game where you can walk around in that environment 50,000 years ago and see what the landscape looked like, what the plants looked like, and understand the archaeological sites in new ways. Now, it sounds cool, but it sounds kind of trivial, but think about our landscape here. So 50,000 years ago, Gulf St. Vincent would have been empty. We would have been able to walk to Kangaroo Island, which sounds quite appealing, actually. Certainly better than catching the expensive ferry. And so if we're trying to understand the way that people that were living here then experienced this space, we need to understand the space itself. Otherwise, our archaeological interpretations will be really biased by our modern perspective. So finally, thanks very much to the people that support this work, but I want to finish on a local note. So Flinders has partnered with the new Glenthorne National Park, and we're doing all of this sort of really innovative research on the stunning archaeological record there, and we're training the next generation of archaeologists there as well. So hopefully there's a few junior archaeologists or not so junior archaeologists in the audience. I should say my mother-in-law, who might be watching online, just signed up to do a master's in archaeology. I shouldn't say how old she is, but she's older than me, let me put it that way. And so there's a place for you to come and enjoy the wonderful archaeology of South Australia as well. Thank you very much.
Final door prize. There we go. Now, whoops, sorry. Now we have the final door prize.
It's green ticket E081.
E081. Who's the lucky winner? Oh, how wonderful. Let's just take a look. Oh, congratulations. Would you like to go and see Catherine? So I'd like to ask the speakers to now come to the stage, and let's see if Dominique is still online. Hello, Dominique. Dominique, are you there?
Yes, I'm here. I'm just brushing my kids' teeth. I'm listening and I'm here. You just don't want to see this.
Well, we're now having our panel session, so certainly any question. So Dominique will be as much a part of the panel session as the other speakers. So remembering, of course, Catherine's going to be looking out for very clever questions or the funny questions to give merchandise to. And any kids in the audience, if you ask a question, you're guaranteed a prize. So that's a pretty good deal. So what would you like to ask of our current panel, including Dominique, who's currently brushing his children's teeth? There we go.
A question for Indiana Jones. What are the job prospects like for graduates of archaeology studies?
That's a great question. I've had so much practice at this because we just had our Flinders Open Day and I was attacked by many, many anxious parents. Strangely, the kids don't ask that question. But it's a good one and it's an important question. And the answer is the job prospects are great. There's so much work in archaeology. Of course, it's cyclical, like many industries, but at the moment, archaeology has so much work for mining companies, consultancies, local councils, museums, for the government, so you...
There are also space archaeologists. Sorry.
Yeah, no, it's a great point, and actually we're really lucky at Flinders to have one of the best-known international space archaeologists working there and teaching there, and so my colleague Alice Gorman is doing incredible work on the cultural heritage of satellite debris, cultural heritage of moon sites. So if you're interested in that, I know she's always looking for PhD students to work on it, so come along.
We have a question here.
So, Space Lady, as in how far will we get all our space tech?
Oh, that's a big astronomical question. Yes, I love my puns. Oh God, in the next 100 years, honestly, in the next 10 years, it's already going to be quite an expansion. I mean, there's missions already by 2026. They're going to see the missions going to the moon, and then Mars and beyond. I imagine that within the next 100 years, we might even have a colony on Mars. That would be possibly, but don't quote me on that. No promises, but yeah, that's where we're working towards. But we've got a lot of research going into the area, which is exciting, but also a lot of roadblocks to get over as well. Like some of the research being done at the University of Adelaide is all about how do you feed people in space and how do you grow food in space, and so it takes about 6 months to get to Mars using current technology. And we can't even carry the food enough. We can't pack enough in our spacecraft to feed us just to get there for the 6 months, let alone to establish a colony and beyond. But they're working on ways that we can grow stuff on the journey there. And one of the cool things is duckweed, apparently. Apparently duckweed's very nutritious and you can grow it really easily in space, so... Yes, it's
We have another question here, and it's a previous questioner.
This is about space. When do you expect us to get the first living thing on Mars?
Another good question. Within the next 100 years? But yes, I really don't know the answer to that. But yeah, he's straight over there. He's gone.
So now we have a question here.
I have a question for Sarah. I'm worried. Worried, that's not the word I meant. I meant wondering.
Could be worried as well.
No, I'm not worried. As a society, or what families can do. I'm a psych student and I work in allied health, so I'm just really curious about the practical implication for families and what they can do going forward.
No, I think that's a very important point, something I certainly did not have time to even touch on in my 6 minutes. I think it's multiple fold. There's obviously the point that if we start understanding better the biological systems that are implicated, that maybe there's this idea of improved pharmacological interventions, but actually it goes beyond that. So something I didn't get to talk about is that we know things like exercise and dietary habits may, I'm a very cautious scientist, may reverse some of the effects that we see. Now, we obviously need more trials to actually test that in reality. I know a colleague of mine somewhere is doing some really cool work on this at the moment. Jar, it's like genetic counselling. You've got a glass jar, your marbles are your genes, and then your sand is that environmental factor, which then tips you over, right? So it's about just learning to modify your environmental factors as much as what you may and as much as what you can. And then as far as the intergenerational stuff, I'm hoping we'll see some policy change and implications around that. And biology, let's be honest, biology, I don't know if there's any politicians here, biology has listened more than sociology, rightly or wrongly.
All right, so I'm actually going to ask a question of Dominique if he's there. Dominique? Yes? No? Okay, he doesn't...
Yes, I'm here.
Great. I'm not sure if you can hear me well, but I just wanted to ask, what are the future steps for your research, like the fact that these reefs are being restored? What's the next implication, especially in lieu of the warming oceans? Is that work going to be undone to a degree?
We've got a lot to learn about what particular sounds resonate with what particular organisms. So what we do at the moment is we play a typical soundscape of a healthy habitat, but we could potentially just isolate components of that soundscape to just focus on oysters, because we want to bring oysters in, but do we want to bring the fish in those oysters? Not necessarily. And so we're interested in understanding how different components of the soundscape influence different animals that respond to it. And also, how do we deal with anthropogenic sound, which is increasing in the ocean and changing the marine soundscape in general? That's a big challenge.
Okay, thank you very much. We have a question here.
This one's for Sarah. What are your thoughts about the use of prescribed antidepressants and antipsychotics to treat mental health disorders? What alternative treatment options do you think are reliable?
Firstly, I'm not a psychiatrist. I'm also not a clinical psychologist. I am a scientist. So that's my disclaimer, right? Now, you may have heard that paper that made a big splash to do with the problem with depression and psychoses more generally as well. Is that there are multiple chemical imbalances. They're not a single chemical. Now, the use of medication, that's got to be based on what your psychiatrist would suggest. Depression is usually your GP, at least initially. I'm not anti-prescription. I think it has its place, but we know there are issues, right? There are side effects. Antipsychotics can be brutal. Antidepressants can be efficacious or effective, but not with everybody. So you're talking like about a 50% effectiveness rate. 60% is the usually quoted mark. You can probably bring that down a bit. Antidepressants are most effective with more severe depressions, and again, there are so many antidepressants that you often have to cycle through to find the right one. So it's not that you shouldn't do medication, you should do whatever your GP or psychiatrist is prescribing. As for alternative therapies, I am cautious. I am a scientist through and through. My view is if something works, it's a medicine or a healthy lifestyle. Right? So things like exercise, if you can, things like good diet. We know that's important. We know there's a recent study looking at antidepressant use and diet, and where you have a Mediterranean diet in addition to your antidepressant use, the effectiveness of that antidepressant is much more, and such like. In respect to perhaps acupuncture or other alternative therapies you may be, then it's not that they're ineffective, they're probably relieving stress, and anything that relieves stress is a good thing. I've done some work on epigenetics in yoga that I didn't talk about, very small study because no one has money, but it was very interesting. But the point is, it's got to do with reducing those stress levels. So whatever reduces the stress levels for you is what you need to be doing. But if you need to be taking medication, you should be doing that too. If you need to stop your medication for whatever reason, that's okay, but you talk to your doctor about coming off these medications, because all these medications, if you suddenly stop, can have a really negative effect. I don't know if that really answers your question at all.
All right, thank you very much. So now at this stage, we're going to start wrapping up the evening, but there's a couple of things left to do. So Catherine, there have been several people who've asked questions. So who do you think deserves some merchandise for that? Yes, I'm putting you on the spot. So she definitely deserves a, you know, but separate from the, yes, I think there was a, oh, there you go, the gentleman in the green jumper, if you'd like to go and see Catherine. What were some other popular questions? No, people a bit shy? You didn't seem that shy in retiring earlier. So
All
yeah.
the questions about space.
Ah, yes. Well, I know we had one here and one there, so yes. All right, so with that, I'd like to first say thank you to these tall poppies. So I think they deserve an applause. And we have and we have a small token for each of you. And Dominique, somehow we'll get your chocolates to you. So thank you for attending. So thank you all for attending this evening. I hope you enjoyed yourself and that we see you again next year. Just a couple of things. Again, we'd like to thank our sponsors, National Science Week, Australian Institute of Policy and Science, and the City of Onkaparinga Libraries. I hope you had a fabulous time, and there's one thing you could do for us as you're leaving. So there's 2 surveys that need to be filled out. Apologies that it's 2 surveys. One is National Science Week, because they do like to hear how these events went, just to help them, inform them what to do for next year for each National Science Week. And so that's basically a QR code on the back of the booklet. So if you just basically use your phone to scan that QR code and just answer a quick survey. And the second is the City of Onkaparinga Libraries. They run a number of events, including Science in the South. And the more feedback they get, the better they're able to design events that will better serve you and the community around here. So I would ask you if you could please fill out these 2 surveys. The survey with Onkaparinga is a paper survey, so you can just pick it up and fill it out quickly. Thank you all. Drive safely home, and I hope to see you again next year. Stay warm.